When you click on the link for the precipitation maps, this is what you'll probably find. And just a friendly reminder, you can sign in using the various tools that you used the first time in Country Profile 1 to access ArcGIS Online. But in this case, I believe these are publicly available. Also important about this particular legend, as you can see over here, is the colors are the same for the three different layers or different data sets that we're going to be looking at. And you might also come across this and say, well, I don't know which one I'm looking at. Go to this middle one here, show contents of the map, and then you can start checking off and checking on and playing around with stuff in terms of transparency and moving the order of these however you want. Let's focus in on what we're trying to do here. So to do an example, let's go to our good state of Indiana, where you'll find one of the greatest geographers in the world residing. And we'll go ahead and click on annual rainfall. And what this will show is the annual all 12-month rainfall totals. And so you can start making analysis from this, looking at Indiana. Once again, I suggest clicking on and off so you can kind of see where you're at. And so here's the state of Indiana, of course, your country. You should know quite well by now. But Indiana, what we pretty much have is a pattern in which south of this line here, well, what is that line? That would be the 40-degree north. South of 40-degree north, there's a little bit more rainfall than north of the 40-degree north latitude. It looks like there's also some up there. And this, knowing what I know, this is lake effect snow, and the precipitation increases that happens during the winter time for this particular part of the state. But that's great. So we've analyzed some bigger picture patterns. And so we look at Indiana. It's something you should do for your country, kind of get a snapshot of, okay, well, how wet or dry is your country compared to the rest of the world? Just zoom out and look at the rest of the world. And so we can see Indiana, yeah, we get, a little bit of moisture. I mean, we're not super dry, but we're not super wet. We're nothing like we would find there in the equatorial areas of the world. And so that's good. We can kind of start making some analyses from this and say, okay, well, here we're getting this moist tropical air mass. It's definitely influencing all of this entire eastern coast from the southeast all the way up into New England and up into Canada. And of course, down here in the Caribbean is heavily influenced by a maritime tropical air mass from the Gulf of Mexico and the Atlantic Ocean. So we're starting to make some observations. So that MT air mass is influencing here. Now let's pay our attention to specific times of the year. And so we have other ones here, and I'll go ahead and click off annual rainfall because that's for the entire year. Now let's kind of compare May to October. So for us, that would be our summertime versus November to April, our wintertime. And so we can kind of go on and say, okay, all right, well, definitely looks like our summer is wetter in this particular part of the world and in Indiana than our winter. So we can see it's much drier, a lot more browns, and we go back to our key once again. So this particular color denotes less precipitation. And so we're making analysis. And so what we can say is, okay, what's happening here is because we have a mid-latitude location, Indiana, we're heavily influenced pretty much all year by frontal systems. So we have mid-latitude cyclonic systems, for the most part, that are playing a key role here throughout the whole entire year. But if we look at our summertime, we have more rainfall. So in Indiana, we have more rain in the summertime. So what's going on there? What happens now is this moist tropical air is influencing Indiana even more as all this essentially shifts up even further. Those frontal systems are coming through left and right and all over. And so we have frontal systems coming through even further. When we look at convection types of storms, it's one of our 4 atmospheric lifting mechanisms. We see convection storms in the summertime in Indiana. We don't see them in the wintertime. So think of these as those pop-up thunderstorms. Don't see those in the wintertime, but we do see those in the summertime. So we look at then compare that to, of course, different time of year, and we got a different pattern. So we look at Indiana, pretty much the entire state in the summertime gets rain. But in the wintertime, we're only really down here. And so what happens now is in the wintertime, I talked about how those mid-latitude cyclonic systems affect Indiana, but really only in the southern part. Occasionally we'll get them, of course, dumping rain and snow in the northern part, but in the southern part, because we're closer, although not really close to the Gulf of Mexico, we're more influenced by the air mass there. In terms of orographic precipitation, you can't see any in the case of Indiana because we don't really have any major mountains. And this is, this isn't a really precise legend. I mean, if this was a little bit more specific to Indiana, you would see down here a little bit more orographic precipitation down here in the upland areas of southern Indiana. But that's essentially a way to showcase how you analyze a particular country or a particular geography and then use the precipitation data. And so be able to use, okay, frontal systems is, in the case of Indiana, our number one way in which we get precipitation. And number two, convection. And so that convection happens in the summertime, as illustrated in the more or greater amounts of precipitation in the May to October compared to the November to April.